Okay, well, let's go ahead and get started. Welcome to this webinar. In this webinar, we're going to be talking about what it looks like when you run a machine learning model in the long term. As you probably know, running a machine learning model is different than running, let's say, regular software. Regular software, you put it out there. Unless you change something, you generally don't need to go back and update it, change it, whatever. And Harish Doddi is going to be talking about what it looks like when we have a machine learning model in production for long periods of time. Just to give you a background about Harish and why you should be listening to him, Harish originally started as a software engineer at Twitter. I think that was where we originally met. And there he was implementing the backend architecture for Twitter. So at large scale running this. Then he went from there to Snapchat, started running some of he was a product manager there. From there, he went to Lyft and was using the machine learning models there, running them at large scale for long periods of time. And then he recently, in 2016, co-founded a company called Datatron, and that Datatron is helping companies think about how we go through and we productionize machine learning models for the for the long term. So with that, I will turn it over to Harish to go through and talk about this. As you go through and you see something in Harish's talk, please chat it out, and I will interrupt Harish with questions. Otherwise, we're going to do a bunch of questions at the end. I would suggest you avail yourself of this. It's not every day that you can get somebody in to be able to ask a question like this who's actually done this at the scales that Harish has done it. So definitely we'll get questions there at the end. If you have a specific question while Harish is talking, please chat it out and I will interrupt Harish and ask that question. So with that, we will turn it over to Harish. Harish?
Thank you, Jesse. So just making sure that you can hear me as well as see the screen.
Yep, you're good to go.
All right, thank you. So just a quick introduction about myself. I have worked in several consumer tech companies where machine learning and data science have been used at scale. Have a lot of experience seeing data science teams grow from almost like 0% team to 100 people teams, and I've seen their journey over a period of time. And there are some challenges that is involved, just like Jesse said. The way machine learning models run in production, there are some, it's quite different from software engineering applications that you have a web server or even a REST API. But there are some interesting points that I'm going to bring it in this talk of some of the challenges that we have seen, and particularly if you are thinking about going from one model maybe to tens of models in the near future, but maybe to hundreds of models and even thousands. So today my talk will talk about some of the issues that you need to be prepared, and some of the lessons that we learned, as well as some of the measures you need to take. So with that, let me go through a quick introduction. Um, so today, if you see the whole model life cycle, I would say that the model life cycle goes through some phases. Just like software development engineering life cycle, they have a model development phase where when a business user requests for a particular business use case, they want a model, the model developers, sometimes called data scientists, they actually scramble the data from the data lake. And they try to run different algorithms on top of it to come up with some model that would make initial sense. Once you have models developed where the initial results are acceptable to the users, you want to go through into a proper testing phase. This is very similar to software engineering testing, where you are actually testing the model in an environment, making sure that whatever the model is expected to produce, is it producing or not. And finally, you want to take the model into a real production environment. It's very analogous to software engineering applications. But the thing is that unlike software engineering applications, model life cycle has some challenges. Number one thing is that a model life cycle is a continuous process. Um, so for example, when you develop a model, let's say you have a fraud model, you develop that fraud model, you're doing some experiments. When you, whatever you're seeing in the development environment might not be the same in the production environment. This is different from software applications because usually software applications, whatever interfaces that the design should come, it is the same interface in production. There is nothing changes. Versus, let's say you have a pricing model, the way your users interact with the pricing model is different in production versus in development phase you have some assumptions. Similarly, the second thing is that your production environment is actually the place where you are validating your models. That is not the case with software applications because typically software applications, it goes from dev to testing to production. It's the same interface. Whereas with models, your models might be working very good in a development environment when you have experimented your model historical data, but when it came to production environment, things might change. So these are some examples. Now let me go through into some of the long-term issues you will face. Um, First thing is that when you have like maybe one single data science team, and there are like maybe a couple of people in the team, things might seem straightforward. But let's say a year down the road, 2 years down the road, when you have multiple data science teams, first big conflict you will have is that there will be no standardization of which development tools people are using. For example, in the companies that I have worked, we have seen that early data scientists, they are very much in affinity with some dev tools like just Jupyter notebooks or even like some basic dev tools. But as the data science team grew, we have people coming from diverse backgrounds. Some people don't want to develop in TensorFlow. Some people are using SaaS, SAS, enterprise SaaS. Some people are using even like commercial vendors like H2O and all these things. So first thing is that as your teams are going to grow, you will see a wide variety of development frameworks that they are beginning to use. And this creates a friction usually because when models are taken into production, you need to do work with cross-functional teams. It's not just the data scientist team who can take the models in production. It's a combination of a machine learning engineering team and the DevOps team. And all of these teams need to work together. So that's why whatever is applicable in a production grade environment, you have to work with this cross-functional teams. And also, second thing is often my observation was that when models are being taken into this type of production environments, because of the isolated and siloed environments people work in, there's a lot of duplicated work. And I'm going to cover this point in detail later. Second thing is that there are very specific requirements for machine learning models. Like as I said, for example, if you have a web page and you want to show a different web page for different users, that is a straightforward A/B testing. But when it comes to machine learning model decisions, you may want to show one decision to one users who may react to that model differently versus another decision if you show to another set of users, they may react differently, and this may have cascading effects too. Similarly, you have challenges in place where you want to always make sure that whatever model you are running, current model in production, the new model, new version of that model, is that coming? Is it improving the current model's performance or is it depreciating? Because it's always a comparison and contrast here, game here, because you always have a baseline with the first model that gets deployed. So there are some specific requirements like that. Third thing is often my experience, data scientists, they are very good with the statistical, mathematical concepts. And the engineering and DevOps people, they are very good with the operations part. Often there is a knowledge gap that goes because the way model algorithm works, the prediction works, you need to understand, the operations people need to understand enough on the data science side. And similarly, If the model takes too long to compute, where your users probably leave the app, for example, you're opening an app and it takes too much time to compute the price, that is also a drawback. So that's why the data science people also need to understand enough on the operations side. So that is the knowledge gap. The last one is model decay. So often when you're thinking about long-term models in your work environment, models, unlike software applications, they decay over a period of time. And decay means that your model, it is expected to produce some level of accuracy, but this accuracy levels can drop over a period of time, which means that the model is negatively impacting your business use case. So these are some of the things. So at a high level, just telling you how this usually works in large companies and the places I have worked with. Typically, the data science teams, they are vertical teams. They usually focus on a particular problem. For example, there is a data science team that has pricing. This data science team, they have experts in that particular area, pricing area. Similarly, there can be a fraud team, and similarly, there can be other teams. When these individual experts, they develop the models, they have natural affinity towards certain dev tools. And just like software engineering has so many languages, the machine learning, they have so many development tools out there, open source, commercial, and a mixture of both. uh, when they actually leverage these tools to come up with a model, which is the output from that team, then they actually need to work with some engineering team to help them with a deploying this model into a production grade environment. Because as I said, these models that are coming from data science team, they're really not meant for a production scenario, because in production you may have millions of users interacting with that model online, versus in your dev environment you're probably testing it on few users and all that. Similarly, as I said, monitoring, you may want to monitor these models. And often these operations tasks today, because of the vertical siloedness that gets created, they get focused on adapting some scripts very specific to that team. And that is one way, because when you're small, you want to move fast, and you want to go through that whole process, like what is the effect of this model in production environment. You may be adapted to that. But when you're thinking about scale, like maybe like a year down the road, you may have 20 data science teams, 10 data science teams. That's where you'll start observing that a lot of these things, as part of the production environment, you may be duplicating it across teams. And also there is also a possibility that sometimes like for example pricing, they may have scalability issues, but that is not an issue for fraud team right now, but maybe an issue in the longer term. So some teams might be solving some part of the puzzle quickly, but it is not reusable to other teams. So these are some of the challenges that I observed over a period of time. The second thing is that typically data science teams, folks, they usually develop their models in a typical sandbox environment. It's the dev environment. So in this dev environment, you may have one model that you're trying to base against, and you're trying to come up with some other model, either like comparing this performance, whether it outstands the existing model's performance, or maybe it is trying to improve or depreciate. But here, everything is static in a sandbox environment, because you're not testing anything at scale. You have to make assumptions because it's all historical data you're testing. But when you go into production, real production environment, whatever you have seen in the dev environment, sandbox environment, it may not be valid. And that's why having that model, making sure that model is running alongside the existing model, and really finding the tipping point where your new version of the model is outperforming the existing version, that is a key. And this is like the champion challenger concept too, where you are always challenging your existing model and trying to champion it. And my observation is that if you don't do these type of things, and if you just push models into production, it is going to negatively impact the business use case. So instead of, maybe your existing model that you have might be a better model than the newer version that is coming, because newer version doesn't mean it is good. It's always a game of making sure that this model that you are thinking of, is it performing better or not?
Harish, in your experience, back to that previous one, how much have you seen a previous model outperform, or if they do it the wrong way that you were just mentioning, underperform?
Yeah, so in my experience, data science is a heavily experimental space. In my experience, 50 to 60% of the time, the existing model is performing better than the newer version of the model, even though newer version of the model, you think in a theoretical way that is going to perform better, but it doesn't work like that in the production environment. The rest of the time, one of the key factors that I observed is usually people know do whenever they're thinking of a newer version, they often think of let's come up with a shiny new algorithm and all that. Oftentimes, you can keep the same algorithm, but tweaking feature vector to that model is going to make a big difference. And this is what I observed in pricing, particularly where we got a play of more than 15% profit. And all that we have done is how do you tweak that feature vector that is coming into the model rather than even changing the base algorithm in that model? That base algorithm remains the same, but it's the input that is coming into. And that's why this type of testing is very important because as I said, your way of thinking that, oh, maybe it's a new brand new algorithm or something like that is going to make things different. It may not be correct in production environment. Does it answer the question, Jesse?
Yes, it does. Great. Thank you.
So the next point I was trying to bring is, as I said, data science teams, they are very good at algorithms, statistical, mathematical concepts, whereas the engineering teams and the SRE teams, they are really good at operations, infrastructure management, and scaling and all these concepts. In my experience, there is right now a knowledge gap between these two teams. And because I have been on this side of the table and this side of the table, I really found that often the data science teams, they have enough understanding of the model, but they don't understand the operations complexity. And the engineering team, they don't have enough understanding of the model, but they understand the complexity of the operations. And this is where the whole turmoil comes when you're thinking about scale, because if you don't solve this problem ahead of time, it's going to create a chaos. And that's where, in my experience, for example, data science team often complain, the leaders in data science team, they complained about the engineering team leaders, saying that they are quick on development, but we are very slow on the operations side. But the engineering team, because the engineering team, the way they think is we want reliability, we want stability of the model, all those things. They won't push any model just like that. Because they have to understand the model, and that's like the model is coming as a black box to this side of the wall. They don't get it, they don't understand. And also engineering team frustrations are that they feel that they are the guys who are responsible for production. So if anything goes wrong, it's not the data science team who gets the blame, it's the engineering SRE team who gets the blame. And that is often like going to create a chaotic frictions between the teams, because it's a teamwork, cross-functional teams will be involved. And right now the challenge is that there is nothing that is going to unless these guys understand really deep about how the model works, and also these guys understand the operations part, then only there will be a good collaboration. Otherwise, it's always the fault is on the other side of the wall. Then the next one is the model decay, and I wanted to give an example here. One of our models, which was meant for attracting new users for marketing purpose, it has it was doing at an okay performance where we are getting almost like 100 new signups every week. And over a period of time, this depreciated to like almost like 40, 30. So the reason why this type of behavior happens with models is generally when models are built, you often take a lot of assumptions about the model because you can't do without assumptions. The assumptions can be as simple as like you are thinking that the user is going to behave in a particular way, or you are thinking that this might be the thresholds that the user can tolerate or the business person can tolerate, and so on and so forth. So when you actually come in the development environment, which I showed you, it often comes with a baggage of assumptions, baggage of theories that you have. But as I said, in production, if you don't monitor your model on a continuous basis, the problem is models are going to decay, meaning that it's as simple as, for example, you are interested in a particular topic, like say politics, but the model recommendation is showing you sports related events, or it's a you are like interested in sports, but the model is showing you something related to movies. So it's a mismatch, I would say. So this is actually going to impact negatively the business. And the idea is, as a result, when new users don't come to the table, you are going to clearly see a drop in signups, drop in the revenue, drop in the long-term values, and all those things. So this might, as I said, this is over a period of time. So if you don't have this type of continuous way, just like software applications, your models will impact the dollars negatively.
And what have you seen companies do to deal with model decay?
So that's a very good question. So often, what I have seen is that uh, people they need to have some sort of visibility and monitoring in place if they want to have this type of thing. Just like software engineering applications, you have Grafana dashboards, you have alerts on the Nagios and all these things. It's a very similar thing, similar type of ecosystem that needs to be adopted in the machine learning side, because this is not about really is the model going down or the model not responding. It is about, is the model prediction good for the business or not, or is it not good for the business? Then what should we do? And usually I have seen is that you need to either start adopting this type of procedures, practices ahead of time in your organization, because one of the example is that when marketing models are decaying, if the CMO of the organization comes to, let's say, the head of data science, that is usually not good, because the business person is coming that saying that there are these things not working, and they have to go through it in a one-off investigation fashion. So the better practices is, you may want to either think of it ahead of time, think of it about continuous monitoring, or even pair up with the vendors that can provide these solutions. And Datatron is one of them, actually.
Okay, good. Back to slides. There was some questions on that one. One more slide. Okay, this question comes from Eswar. There is an additional round of training and scoring that you'd incur when you want to certify a new version of code in production, i.e. compare with a champion. How do you balance the cost of running additional training, say for GPU resources?
Yeah, that's a very good question. So if I understand, the question is like, whenever the newer version is coming, you probably need to incur some additional cost associated with that newer version, but you don't know if the newer version is going to work or not in production. So this is where, as I said, you have to, you can probably have a version of that model. You may not train on the whole data set. You can have like a sampled version of that model, and you can try that sample data set, the model that got trained on sample data set, putting it on a A/B testing mode with the existing model. And that will give you enough idea whether this is making sense or not. And that's when you can think about, okay, we need to retrain the whole model at scale to really push in. The biggest problem I observed is people don't have access to production environment quickly, where they can test something out, even if it is a version, sample data set that they have trained on. Because unfortunately, anything in production, it's too dangerous for the organization, because engineering teams, as I said, they will be at risk if something goes wrong in that model. They need to have a proper tools in place where they can try out even a mini version of that model and see that is this like performing better, not better, and you can put it like a couple of weeks time. And if there is enough evidence that this model is performing better, that it can trigger the training at scale.
Talk more about that A/B testing. I know several companies, including Twitter, have put sizable amounts of effort into creating A/B testing frameworks like this.
Yeah, sure. So first of all, I wanted to emphasize that A/B testing in machine learning models is quite different from software engineering applications, because as I said, in machine learning models, the decisions will come on how the user reacts to that model. For example, you may find that a particular price that you are showing to the end user might be okay, but until you actually go into the production environment, you don't know whether that is a viable decision or not. And that's where what we have seen is that A/B testing, you can go at the global level where all your users, but you can also go at individual segmentation level. For example, in one of the companies I worked, there is a model that we have thought initially that it will be one model for the whole users in the company. But then we realized that because of the way the users are reacting to this model, we need to go even deeper. Because when we are doing A/B testing, we found that a user living in a particular city like San Francisco, he's behaving differently from a user living in New York City. So if you have one single model at that time, then your model is probably performing very well in San Francisco. But you often get this question: why is this model not working in New York City? That's where you need to think a little bit out of the box and even come up with segmentation on the users. Maybe you can have one model for San Francisco, and then you can have a model proper A/B testing in your version of that model versus another version you can have for New York, and then do A/B testing. So this problem can become increasingly complex, right? Because as number of cities grow, you almost have one model per city, but within that city, you can have maybe two versions of that model you're A/B testing. So that's where the whole complexity comes at scale.
It's interesting. I haven't heard of A/B testing down to a city or down to a region like that. That's interesting. So the next question was on one slide forward, and that was on this knowledge gap. And you're obviously leading up to talking about MLOps and talking about that, but this kind of tells you, where do most companies get their MLOps from? Is it somebody from the data science team, or is it somebody from the engineering SRE team, or both?
So that's a very good question. Often I have seen a mix of things. Usually the affinity is to get some person from the engineering SRE team who is going to learn this part. And that's where a new role is getting created, which is called machine learning engineering role. This is very similar to software engineer, but the skill set is this intersection, which is lacking right now, and someone from the engineering team steps up and understands this part. This is what I have seen most commonly, but I have also seen some companies in which one of the data science team members steps up to go into this side of the picture. Does it answer the question?
Yeah, how long have you seen that take on given both sides?
So that the in my experience, stepping up from the engineering SRE team, understanding the data science is usually faster than a data science team jumping onto the other side. Usually, it takes several months, I would say, anywhere from 3 to 6 months, depending upon the complexity. But as I said, that the problem is that you may be doing two specific things for a particular team or something like that. So this is something that maybe whatever they have learned will be very specific for this particular team that they're doing rather than applying at scale.
Excellent. So a call out to everybody who is participating and watching. Ask your questions in the chat and I will ask them to Harish. All right, go ahead, Harish. I'm sorry.
No problem. Um, so then I just covered the model decay over a period of time. Then I also want to like tell where how our companies handling it. Today, what I have seen the practices is typically data science teams they actually pair with an engineering team. Like it's almost like a hand holding type of thing, heavy hand holding. This engineering team's responsibility is to satisfy the data science team for any production related requirements on the model. And that's where what I have found out was that this engineering team they will be developing some tools, some scripts, some sort of frameworks to help these guys. And similarly, since data science teams they are a vertical focused because they are a business case focused teams. Some team will be focused on a marketing related use cases. Some team will be focused on a fraud related use cases. Another team will be focused on a pricing related use cases. So there is a heavy coupling between these two teams. And as you are thinking about next use case, next use case, there will be this type of heavy coupling between the engineering team and the data science team.
So related to that, what have you seen at companies that lack that coupling? In other words, there's just a data science team and no engineering team there.
So I think that is a very unfortunate situation because in that situations what typically happens is the data science team one of the members tries to step up and do this whole thing, and in my experience the problem is they may not see the problem right away, but when things are scaling, they will hit all issues, complexity issues in the infrastructure management, complexity issues on containerization process, complexity issues on infrastructure monitoring, model monitoring, all those things. So that's like almost like as I said, you may not see the problem if you have one model in your organization, but as you're thinking about tens of models to hundreds of models, you will be realizing that you are having too many resources dedicated, and that's where they will be realizing that they don't understand a lot of operations work, which is the expertise of this team.
Good. There was a question from Eswar again on the model drift slide. He says, could you elaborate on how you monitored and handled data drift, i.e. patterns and data that can change over time? This is not something that ETL data engineering team can judge as a simple DQ rule. A basic example is distribution of gender and population, which can change over time, impacting model performance. Did data scientists share the assumptions with engineers and then engineers implemented a check?
Yeah, that's a very good question. So I talked about the model drift, but the question is on data drift. Often what happens is that, because ETL is a complex process, and it's usually involved in the upstream because in the downstream is where the data science models are getting built. Any simple change in ETL or any simple thing that got broken in the process is going to affect the whole data science pipeline. And it's a big challenge because it can be as simple as the model is expecting three features, but you are supplying like maybe like two features only. Or it can be as complex as the model is expecting three features, but one of the features it's expecting is a integer, but you start supplying strings. So this is all the situations that drift can happen. And if you analyze these type of scenarios, there are roughly 20 scenarios, I would say. The best mechanism that I found out was from the experience. In order to cover these type of scenarios, it's often the best policy to understand the model requests that are coming to the model, understand the model responses that the model is getting, outputting, and storing this over a period of time so that you can perform some sort of anomaly detection on this type of logs and understand that is the model, for example, it's expecting something but it's getting something else, or is something is broken on the assumption side. It doesn't matter how many assumptions the data science team share with the engineering team. Often converting that into a practical thing is not possible because they will have so many assumptions and they're very complex. So the best strategy that I found was that number one thing is whenever something changes in ETL, there should be some sort of registry that that's going to communicate that a lot of things got changed, model dependencies, all those things. You need to start building it internally. That how is this going to affect? These are the 5 models that are going to impact and all that. Second thing is you should start thinking around some sort of checks that can automatically understand is the model getting the right number of features, or if the model is getting not good features, not the right number of features. Similarly, thinking of different scenarios. Third thing is you may even have to perform anomaly detection on the logs that are getting generated to really scrutinize that is there some sort of behavior that is not in alignment with what you're thinking. So does that answer the question?
I think so. I think that was a great answer. So back to that slide that you were just at, there was an observation from Laxman. If you go to that slide, it was the one with the data scientists and interfacing with the data engineers. One more over. No, to the right. That's the one. Okay, so Laxman says, nowadays, most of the MLOps guys call themselves data scientists. And I'll put my 2 cents in there, and then Harish can do that. If your ML ops guys are data scientists, you've lost. You, I think this slide is showing the usage of the data scientists and the data engineers, how they should interface. If you're missing that, that's a big problem. If your data science teams are the ML ops people, boy, you've got some real problems there. And then he goes on to say, this is one of the best presentations, giving the value brought by MLOps teams. So, hey, kudos to you, Harisha. And so I would echo that. Great job. So what do you think about that, MLOps being the data scientists?
Um, I think I'm going to echo the same thing that you said. I think that's not a good idea, having an MLOps to be a data scientist, because as I said, it's like this, right? Like there are experts in certain areas. Like you are asking a designer to write code for you, or you are asking a QA person to go and figure out an analyst job. That is a mismatch, I would say, in terms of the skill set. It may sound completely straightforward. As I said, if you have someone who, like, if you have a small organization of like 10 people and everybody has to do everything. But when you're thinking about an organization as the organization scales, or even like large enterprises, that's not how things work. Every field has experts, and they are the experts who have foreseen these problems ahead of time. They think differently. Their priorities are different. Simple use cases. Data science teams is always hungry about the next algorithm. How can I increase the accuracy by 1%, or how can I do this by 3%? I'll tell you a classic example that I've encountered practically, where the data science team wanted to increase the accuracy by 1%, and that's going to impact the business a lot. But what they have forgotten was increasing accuracy by 1% has increased the whole computing frameworks. And in return, the whole SLAs got increased, where they were not able to reach that SLA for all the model responses. So as a result, instead of improving the model by 1%, they are actually timing out. Model is timing out. And as a result, instead of improving their business, their whole bottom line got affected. And then there was this whole fiasco that why did we even approve this change of improving this 1%? Because it has impacted the whole model production environment negatively. So they wanted a quick rollback button or something like that, where they could have rolled back to the previous version, even though the previous version accuracy is lesser than the current version. So I would say that, as I said, these MLOps type of skills, their way of thinking is different, their way of analysis is different. They care about things differently, and that should be the criteria, I would say, because data science teams, their incentive is one incentive, whereas the engineering teams, their incentive is different incentive. You can't put one guy in one team cross over to the other thing. I don't think his incentives will change, because he will be adapting to the base incentives, and that is a mismatch, in my opinion. Does it answer the question?
Yeah, I think so. That was, I don't know about the other people, but I'm really enjoying the fact that you have firsthand experience on this and we're not sharing something theoretical. And that's it
Yeah.
for the question so far. So go ahead.
Awesome. Um, So then, and also one thing I wanted to emphasize is that it may sound like this is a new area, new list of tools that I'm talking about. But think about the days where there was no software testing. There was just development and all those things. That actually started the new ecosystem of tools for software testing. Same thing with software deployment tools. The reason why all this software deployment tool, there's a new ecosystem that got formed, is because that's a different type of problem that they're trying to address. You can't just take a normal script and say that, hey, this is a deployment script, this is the dev thing and all that. You can't mix all those things because they have different uses, purposes. Machine learning, since it is right now in early stage, we are recognizing this. When you're thinking about scale, you need to have a separate set of tools for the MLOps. And that's where I'm trying to bring my practical experiences in all these problems that are happening. And again, it's a matter of time you will hit these issues. And when you hit these issues, it'll be so worse because the business people will be like, oh, why don't we have tools like that? It's as simple as that. But having these tools, thinking about all these problems ahead of time, that would be the key. And unfortunately, because it's not a mature field, it's a field in its infancy stage, a lot of people don't understand the problems that they will potentially get. So on that note, I just want to give a quick introduction about Datatron here, and I want to keep it simple here. We are providing a centralized MLOps platform where any models from coming from data scientists of any types, whether you are using Python, whether you're using TensorFlow, or even commercial vendors like H2O or anything like that, we provide a centralized platform of MLOps where all your models are managed, and we bring resources like deployment, monitoring, management, A/B testing, champion, challenger, all of this at scale through automation. And that is the main ROI of this whole platform, because this platform can be interacted by three types of users: data scientists, engineering teams, and DevOps teams. And what we have seen in our experience is we are accelerating the whole model lifecycle management by decreasing the time from model dev to production. So as a result, your models can go to production environment faster, but also we're making sure that they are resilient to failures. So if anything happens, you have ways to recover quickly. And also, since there is a continuous monitoring mechanism, you get alerts, just like software engineering. You get alerts whenever the model is drifting, whenever a model has issues. And accordingly, these alerts can be consumed by these three teams to take a decision what to do with that model. And we have seen in our experiences what is taking people months of time doing this operations work, we can actually accelerate it to a few minutes. And that is the main ROI of this platform. And the way we do that is part of it is data scientists, as I said, their job is to actually come up with the best algorithm, come up with the best model for their business use case. We don't want the data scientists to do the operations part. Rather, we want a central platform which can be managed by the engineering SRE teams. So when the data scientist registers the model, the whole process of deployment, containerization, monitoring can be done in few minutes setup. And as you can see here, when you have very less number of models, you might need as your models are increasing, the number of people who will be benefiting from this platform, you don't need a lot of people to coordinate. And that is the main benefit of this platform, because otherwise when you're handling 5,000 models, you might need a team of 50 people on the MLOps side, and that's the main benefit. I think with that, I also wanted to cover a last slide, which is the model decay. And the idea behind this is how we are helping is because we have automated the whole monitoring and decay process. Whenever you have the ability, the SRE person and engineering person, to configure what are the thresholds that are acceptable, so that whenever the model is decaying, the alert gets triggered off. And accordingly, uh, when the user takes an action on that alert, you can recuperate the performance back. And that this is how is the reality that works on the model performance. So I think I can take any question and answers at this point of time.
Excellent. So while you are putting in your questions into the chat, I will ask one about that previous slide. Is it true on and even in production that you see a sawtooth like that?
Yeah, I think usually in production, if you don't take care of the model decay, it's usually decaying and it's always going in the negative direction. But in production, as I said, model decay is going to take time. It's not going to be something that in real time you will see the model decay. You have to observe this over a period of time. So usually it happens it like this. And whenever the model decay, as I said, you have to configure what is the healthy threshold for that model. And typically, each model may have a different type of healthy threshold dependent upon the business use case. And that's why whenever the model is decaying, the alert gets triggered. Sometimes the user can react to the alert where they are doing something about a newer version of that model or changing that model or rolling back that model. Sometimes they may say that it's still okay. And accordingly, maybe it's a seasonal effect that might happen. And that's where the model can be recovered. As you can see in the recent coronavirus that is happening, there are many models that got impacted actually, and because this is something that happened over the last couple of months. Now, if let's just say that coronavirus is not even there in the next couple of months, hopefully, all those effects can be reversed actually. And that's where this is where the user is the best person, and the user is, as I said, is a team of engineering data science people. They are the best person to judge whether they want to take any action on that alert or not.
And so there was a question before, and maybe it's a good time to re-ask that or to reiterate this. This user alert, is that created by the data scientist who originally created the model, or is it created by the MLOps person?
It's a combination of both, because data scientist people, they focus on one type of alerts, and engineering people, they focus on a different type of alert, and some alerts can be a hybrid among both of them. Our platform is giving them the ability to configure these alerts, whether it is data scientist or engineer. And the idea here is when the alert triggers, it goes to all the teams involved in that who are the stakeholders in that model, and they decide what to do as a team.
Excellent. We have a question from Rajdeep who says, what should be a roadmap for a data engineer to get into this MLOps role?
So I think it's a it's a complex question that you have asked. It's so I think in my experience, unfortunately, this is not like a course that you can take and you are certified as an ML.
Having that practical experience. Sorry, can you guys hear me?
Yeah, I can hear you. It looked like it sounded like there was some kind of weird audio.
I think maybe
issue.
my audio was having issues.
We can hear you, Harish. Harish, can you hear me? Okay. It sounds like you may be having.
Hello?
Yes, we can hear you, Harish. Harish? Okay, well, Rajdeep, I'll answer that question while Harish is trying to figure this out. Yeah, we can hear you, Harish.
All right, can you guys hear me? Sorry about that.
Yes, we can hear you, Harish.
All right.
You can hear us? You can hear me, Harish?
Yes, I can hear you. Sorry about that.
Oh, no problem. So would you like to re-ask the question?
No, I think I got the question. The question is like, what type of roadmap are we looking at for a data engineer to get into this MLOps space? So as I said, that unfortunately, this is a not something like a course that you can take and you can say that you're certified on this. There are a lot of practical challenges that really come into picture. I would say that you need that practical experience where you have the freedom to make errors, because if a data engineer is doing this first time without experience, probably in the first 6 months there will be a placement for a lot of error that happens. And if you plan to invest that type of thing, I would say give yourself at least 6 months to 9 months of time so that you can put some models into production and face those practical issues. That would be the best way to learn this type of things. And that may have some impact on the business as well, but that's an investment that you are thinking to put it. And you may need to understand some of the concepts, like for example, what is drift, what does drift happen, when does drift happen. You may need to understand some real talks on what are some of the practical challenges that are going to happen infrastructure wise. You need to understand things on the training side. You need to understand things on the data science framework containerization, because every framework is different. So for example, if your organization is using Python, if your organization is using Jupyter notebooks, or even Anaconda, or even like some other frameworks like other commercial vendors, you need to really understand how those frameworks work. Because until you understand what type of algorithms are they providing, what type of algorithms your data scientists are using, practically you may not be able to get these things. Now, you may need to also pair up with some data scientists in your group to really get these concepts to your understanding quicker.
And I would also add on to that, Rajdeep, maybe your better route is to go with actual ML engineering to become a machine learning engineer, that one that he was talking about originally of being a data engineer who learns the data science side, not necessarily doing the operations, but helping the data scientists productionize correctly. And that may be a not just a better route, but a more profitable route for you personally, as far as amounts of salary, et cetera. One question before before I forget: how do people get a hold of you, Harish, if they're interested or they have a follow-up question?
Oh, I actually shared my email address here,
Oh,
so you
there it
can
is, right
reach
there.
out to me.
So,
Through email is the fastest way for me to get back to you for any questions.
okay, so there's a question from Harish, or excuse me, not Harish. Harish will not ask himself questions. A question from Chris. He says, some models are like a simple function, e.g. fn xy equals result. In conversational AI, there may be a series of interactions, e.g. text to intent to callback. Is there anything different about this use case we need to look at with regard to model decay, etc.?
Yeah, that's a very good question. The thing is that with conversational AI, let me tell you an example, right? Like, let's say that you have a chatbot. You ask a question to the chatbot, maybe like you want to say, like, look at my case status or something like that. The complexity of conversational AI is multifold, because the way people interact with the chatbot will be different based on in region, based on country, based on demographics. It can be all different. The that type of model, when it responds to that user question, um, you may have some sort of feedback that says, did this answer your question? Just like, in our call centers, we get this, we want to take a survey, did we do this type of thing? Just like that, very similar to that, you can have some sort of feedback that says, did this answer your question, from the user? And that can be as simple as a simple thumbs up. That is where the feedback really comes about the model. So in conversational AI, unfortunately, it's you have to understand the models, how they're responding, what they're responding, and you need to uh, connect it, whether that response is relevant, and it sufficiently answered the user question or not. And and you need to think about those type of things, because sometimes it also is like, maybe the query answered 50% of the answer, but didn't answer 50%, rest 50%. So you need to think about all the scenarios and come up with the performance metrics.
Well, good. It looks like that's the end of our questions. There's one from Jose that's a final question. If people were to email you, would you be willing to send them the presentation, the slides that you
Yes,
just did?
definitely, and I will share it with you too, Jesse, so you can actually send it to the people who attended the webinar. I'm happy to
Yes.
present the presentation.
And related to your question, Jose, yes, this webinar is being recorded or was recorded. And so we'll be sending that on as well, so that you could either send it on to people in your organization or rewatch certain things. Well, it looks like we're it for questions. Is there anything else you'd like to say, Harish?
No, I think thank you so much, Jesse, for giving me this opportunity. This is a topic that I have a lot of depth and have a lot of experience, practical experience. So please feel free to reach out to me offline or anything, so that I can give you my thoughts and my experiences. I think, as I said, this is a new thing that is coming. This is something that you need to be braced for the impact, something that you need to think ahead of time and fix it. Otherwise, it is going to create a lot of chaos in the teams.
Well, excellent. Well, thank you again for sharing your experience with us, Harish, and everybody that attended. Thank you for coming, and I hope you enjoyed it, and have a great rest of your day. Bye.
Thank you.